Thank you, sir. Now all the technical papers have been divided into two sessions. Session 1 consists of two papers and session 2 also consists of two papers. So now I invite chairman and co-chairman of the session. Now first I invite chairman of the session, Sri B. Bhaskar Garu, Director Operation, Singareni College Company Limited. Please, sir. He is an alumnus of Kottagudem School of Mines. Previously, he has worked in many managerial positions in Singareni, like General Manager IT, missionaries in Adriana Langwall project, first time in India with a capacity of 2 by 1152 tons capacity. And he is also man behind the introduction of information technology programs such as SAP and others in Singareni College Company Limited. And he is known as not only GM, not only director, he is known as IT Bhaskar Garu. I thank you, sir, for having this occasion. And now I request Sri Radhakrishna Garu, DCM R&D, to act as co-chairman of this session. He is now Deputy General Manager, Research and Development Service Singareni. Now I hand.
Good morning, I pay my respects to our lecturers, staff of existing staff of KSM, not KSM now, College of Engineering, Calcutta University. I see my seniors, friends, also not many students, young students, future engineers. Mining at the how many mining? Other, okay, mining other. The girls are also there in mining. Right. Okay. So it's predominantly okay, other disciplines the corner. So anyway, first I regret that I'm little late. Out of my office compulsions, I'm little late. But anyway, I'm glad that I'm able to be with you. Anyway, afternoon session is there where we will be able to share the other thing. Probably most of you will be there also. So now we will stick to the technical sessions. I came late, but I could see that the structure with the keynote address, probably most of the things that are required are already covered. Environment, right now also I was just coming from the office. The most of the thing is that as a mining engineer, you don't just need to look into the ground. Now that those have gone, where you need to see only the geology or other things. Unless you see the environment, whether it is a forest land, whether it is a eco-friendly area where you can mine, whether there are sensitive areas, whether there is R&R. See, an extremely good deposit is not a really a good reserve for you, unless it is environmentally and socially acceptable and you can mine it. So it is not the reserve that is really, when we say the reserve base, most of the reserve base which we say may not be a reserve base for us, because it is not, it cannot be areas where they are more sensitive onto that. So as mining engineers, unless we understand that, so we must be able to mine economically, not the geologically good deposits, but the deposits where the mining can be done. Those deposits are required to be made, should be made technically feasible and economically viable. We are only trying to say that we're technically feasible, economically viable, then socially acceptable. Then we try to say once this deposit is there, how to make it socially acceptable. It must be environmentally, it can be mine friendly, then it should be socially acceptable. Those deposits you pick up, then they should be then you must mine them technically and economically viable. The technologies are in our hands. Environment is not in our hands. So you cannot, you can generate technologies. That is an engineering challenge which might be able to take up. Whereas the environment and those things are not in our hands. So we cannot compromise on that. I think that is the spirit for the way that the next generation, probably we will be returning in 2-3 years. But the next generation, probably this is the challenge that we need to undertake. So under this context, taking up this type of topic by the technical part it would have been much drier and probably is much relevant to that. So anyway, but the time pressure, I think today now most of us will be looking after to meeting the afternoon session. So I request the authors to be very focused, and the time given here is 15 minutes. But I don't think in any seminars and all that we need 15 minutes to tell very focused points. So I think 10 minutes should be the maximum that we must be able to have onto that. But the 7.5 minutes, actually 15 minutes, 2 papers should be the norm. So I request the speakers to be very focused and try to conclude, so that most of the things have been taken by keynote address. I think the message has been very clear. So it's only need to understand onto that. So I request the first paper presenter, sir, Ramalingeshwar, who is presenting? Ravikiran is presenting. So Ravikiran, I ask him to make a very brief and quick presentation. Right.
Good morning, sirs. Really, it's a privilege for me to talk in front of the director, sir, and other elderly persons. This is like తెలుగులో మనకి సామెత ఉంది, తాతకి దగ్గులు నేర్పించడం అంటే వాళ్ళు చెప్పింది మళ్ళీ వాళ్ళ ముందు వాళ్ళకి చెప్పడం అనేది ఎంతవరకు నాకు కొంచెం భయంగానే ఉంది చెప్పడం. యాక్చువల్గా సార్ మీటింగ్లో ఉన్నారు, కొంచెం లేట్గా వస్తారులే అని చెప్పి అనుకున్నా, కానీ వచ్చేసారు. నేను కేవలం స్టూడెంట్స్ ఉద్దేశంలో పెట్టుకొని చెప్తాను సార్.
I think this is only, you must be able to reach the students. This is important.
Thank you.
This is a presentation.
With this, please allow me to speak a few words on the environmental impact assessment. Actually, what we have, due to lack of time, whatever that is there in the existing has been presented here. But in the night, I thought at least some 1 or 2 slides shall be included in the introduction, so that what is environmental impact assessment for the benefit of students. But when I have come here and have seen the keynote address, Professor Chandrasekhar has already touched upon all the subject, all the things what the environmental department of a company will be doing. Right. Coming to this, this is the process flow diagram of the environmental impact assessment mining project, and then we have the mining plan approval. In addition to that, we have the Form 1 preparation. So basing on the pre-feasibility report submitted by the project planning, we will prepare the Form 1 and submit to the Ministry of Environment, Forest, Climate Change. And basing on that, they will convene a meeting in which we will discuss the various aspects of the project and what are the basic, the fundamentals of the project, and they will issue the terms of reference, what is called TOR. And in the TOR, they will mention the various conditions, like what are the various studies that should be undertaken by the project proponent in order to have in order to obtain the environment clearance. So depending upon the study or depending upon the nature of the project, you will be asked to conduct, suppose for example, if it's an underground mine, you will be asked to conduct a subsidence survey or subsidence study. Or if it is an open cast mine, they may ask for conducting of the impact of open cast mining on the surrounding flora and fauna or the villages. Like that, they will be asking, in addition to the general terms and conditions, they will be asking for the of the project. And for that, we will be going for, and then in addition to that, they will be going for the public, they will be asking for conducting the public hearing. This process contains in 4 steps. One is the screening, second one is the scoping, third one is the public consultation, and fourth one is the appraisal. So in case of screening, as earlier speaker told, that whether it is a project under A category or project B category. So definitely coal mining comes under A category, and for that screening is not required. And then you have the scoping, in which what are the aspects that should be in the area will be under the scoping concept, the scoping category. And third one is the public consultation, where we will be going for the public hearing, where all the issues pertaining to the environment will be addressed, and the opinions and the advices from the public will be taken upon, and that will be included in the environmental impact assessment report or EIA EMP report. initially the draft EIA report will be prepared, and later, once the public hearing is conducted, the final EIA report will be prepared basing on the advices or the recommendations of the public in consultation with the collector and other people, and the final EIA will be submitted to the Ministry of Environment and Forest for the appraisal, for the expert appraisal committee for obtaining the environmental clearance. So if they are satisfied, then of course the project approval in the ESC meeting, and project is okay, and project will be, the EC will be granted. Otherwise, if there are any queries, they will be asking for the proper queries and we will be submitting the accordingly. Next, please. Generally, in an EIA report, these are the common contents. Like the first one is introduction about the project. Next is the project description, the need of the project, location details with maps, technology, and project description. And third one is description of the environment, baseline data, base map of all environmental components. So baseline data is that before establishment or before commencement of our project, what is the present situation of the environment at that particular site within a radius of 10 kilometers. So the project site is considered to be the core zone, and the 10-kilometer radius is considered to be the buffer zone. So what is the impact of the upcoming project on the buffer zone is going to be addressed in the baseline data. So baseline data is a study conducted for a period of 3 months by a NABL accredited institute, and in which the air, water, noise, socioeconomics, hydrogeology, etc. parameters will be taken into account, will be considered, and they will be monitored for a period of 3 months. Earlier it used to be for a period of 1 year, but because of the speed and the rapid BLE is being developed nowadays. And the anticipated environmental impacts and mitigation measures. So whatever that is there from the BLD after 3 months study, then we will extract the data, and that will be used for predicting of the environment later when the project has come up. Once the project has come up, what will be the changes in the scenario in the air, water, noise, etc. And that will be predicted. Like for air, it will be by using the air mode software, where the PM10, PM2.5 particulate matters and other things will be taken into consideration. And like water, various 30-40 parameters are there. And noise, how it will be done. Noise modeling software is there, for which if you have so many dumpers, if you have so many drills, and if you have so many shovels, what will the increase in attenuation in the noise will be also calculated. In that way, once the project has come, what will be the anticipated impact also will be predicted or included in the EIA report. Next is analysis of alternatives, technology and site has also to be included. Where as far as the coal mining is concerned or the metal mine, there will be very less possibility of, or even there is no possibility of site alteration, because depending upon the content of the mineral only we can go for the mine. And
Last 2 minutes.
yes sir, okay. Environmental monitoring. Yeah. Okay, I will just come into this one. These are the various parameters, and in this one I am just dealing with the land degradation. Next one. Next. This, of course, this is for introduction only. Next one. And SSCL is operating in 6 districts, and this is the assets of the CCL. Next, please. Next. Open cast and surface mines, and open cast play a major role in the environmental pollution. Next. Next. Yeah, next. So, particularly I am dealing with the land degradation, in which we are taking the engineering measures and the biological measures. Coming to the engineering measures, whatever the OB has been removed, next. OB has been removed will be dumped into the open overburden dumps, and that has to be reclaimed by means of various plants. And that for just planting the seed or sowing the seeds on the OB dump just doesn't make the plants to grow. So for that we have to have a number of engineering measures, engineering constructions has to be taken up on the OB dump, like toe walls or garland drains, gabions, cribs, etc. So that you have to prevent the runoff soil erosion, and then only the plants can grow properly. Next, please. These are all comes under the engineering structure. And coming to the biological engineering, the treating the seeds with VAM, rhizobium bacteria, etc. will be under the, and raising the quality plants in our nurseries, and then taking them to the OB dumps and then planting, attending with proper care, and this is all done in the biological measures. Next, please. And also we have to engineering measures. We have to maintain the slope of the dumps, etc. has to be maintained. And next, this is the slope we have to maintain, and these are the garland drains, these are the toe walls, berms, etc. How you have to maintain. Next, please. And this is the sectional view of the OB dump. And if you go for the next slide, that is the top view. Next. That is the overall the first bench with a road over there, and then garland drain, and then the inspection road. Next, go on, proceed. And this is the first deck, and again there is a garland drain, and around there the inspection roads, like that. Second deck. In the meantime, on the slope of that first deck and between the first deck and second deck, you will be taking up the plantation, and again in the deck 2, the toe walls, the garland drains, etc. And in between the deck 3 and deck 2, again they will be taking up the plantation. Like that, you will be taking up the plantation on all the decks, and you will be completing the reclamation. Next. And in addition, okay, next. These are some of the structures what we are being done. Next. Okay, and coming to the biological measures. Next. Well, these are previous. Yeah. These are the the OBs where the soil erosion can be prevented by the roots of these species, like agave or soil binding species, and hemata grass will be shown on that, and bambusetum. Next. These are the just views of those things, and previous. This is the if you see this is the earlier the first dump, the first scene of the OB dump, and that is how the planting will be taken up on the OB dumps. And at the final stage, this is the reclaimed OB dump, which you will not believe. It is similar to the forest with all the water bodies and everything. And we have a number of lively examples. If we go to the open cast mines where they are reclaimed, like you can find a number of reptiles or snakes or birds, etc. The forest department is taking care of those things. Next, please. And fruits of these are the various species what we have got into the overburden dump after the reclamation. Even these are the types of these are the various mammals we have noted in the OB dumps. Of course, there are some challenges like high stripping ratio, where when compared to coal India, SSCL has got 1:8, 1:10 stripping ratio, where huge amount of OB dump has to be maintained. And you have the geological considerations, inherent variability, slope and aspect effect. Spontaneous heating is one, where some coal will be left in the OB dumps, which will be again heating the area where the plantation will be a problem. Next is the low fertility of the soil, because that will be lacking in NPK constituents, where the growth of plants is again restricted. And moisture retention, rooting depth and compaction. Here also the size of the particle matters, because larger the size, the water retention capacity will be less, and that's why the size is also a matter. Coming to the high surface temperatures, as you know, Telangana is inherited with high surface sun, and more than 40 degrees always will be maintained. That is again a problem. That is the explanation of all those things. Next, please. Just review. So this is up to 2015, around 9,302 hectares of plantation has been done with 1.71 crore saplings. But as on 2017, it is around 3.72 crores of saplings have been planted in 10,932 hectares, which everyone has appreciated us in the ministry as well as in the pollution control board also. Next, please. So I just wanted to show this last one. Like this is the pre-mining stage of a mine. This is the boundary of the mine. And if you go for the next slide, this is the quarry area, and this is wait. Okay, this is the dump area. This is the coal yard, and this is the quarry area, and this is backfilling. And if you go for the next, so the plantation has been done on the OB dumps and on the backfilling, and this is the void what we are creating at the end of the mining life. And next. And post closure is this is the final scene of open cast mine after the closure after 3 years. Like that is the final plantation has been done here. This is the final, and this is the water body what we are going to leave, which will be developed as a aquatic habitat for the development of the aquatic habitat as well as for the regeneration of groundwater in the surrounding areas. Next please. So systematic planning, this is all the conclusion. Next one. And this is the policy of the environment. To be a role model in protection of environment for sustainable development, SSCL is committed to implement the best global practices in all its operations through prevention, mitigation of pollution, proper disposal or recycling of waste, and bringing awareness among all the stakeholders for continual improvement in environmental performance. Thank you very much, and hope the people have benefited from this. Thank you very much, sir.